What is up, car and tech fans? In our last video, we started making a system where we were going to create a custom controller to alter some underglow lights that we'd purchased off eBay. And what we did in the first video was take a look at whether or not we could use an ESP32 to control some lights that we'd bought off eBay. Because if we couldn't do that, then all of the rest of this wasn't going to work. But we got that working. So what we're going to do in this part 2 is look at how we can take a 1.28 inch touchscreen like this and put a controller on it, which we're then going to be able to connect to the underglow and use this to turn it on and off and change between some colors. This will be really good if you've ever thought about using one of these and you don't know how to set it up, or if you've ever looked at trying to use LVGL, the Light Versatile Graphics Library, because that's what we use to create this. And we're going to do a breakdown and a walkthrough of how we create this thing. But first up, let me just show you how it works. On our main screen, we have an arc, which is basically just showing the color that our underglow is currently set to, and a little on-off power button in the middle. Unsurprisingly, if we press the power button, the system goes off by just blanking those things out. And then if we turn it on again, the power comes on. But if I touch the ring or swipe down from the top, we get this color picker. So I've got some commonly used colors: red, pink, purple, cyan, green, yellow, and white. And if I choose one of these, let's say red down the bottom here, you'll see the arrow at the bottom turns to the new color. It's just a bit of feedback to show me that the color's changed. When I click back down, now this will show red. And similarly, if I go up and change it to cyan, it's now cyan. So this can just sit in the car and I can then just glance down and see what color the underglow is currently set. And after 10 seconds, it dims. So it's not going to be really bright and distracting inside the cabin of the car. And most of the time, I'll be honest, I use mine on purple. So that'll be the go-to color for me. So that's really not going to be too distracting. I'll be honest, the most complex part of getting this working properly was the initial setup, because the specification sheet that came with this board was wrong. All the pin specifications were wrong, and I just couldn't get any code that I uploaded it to actually display on the screen. But once that bit's sorted, it's actually not too bad. But I'm going to help you out, because if you've got this board, I've created a full setup file that you can use in Visual Studio with PlatformIO, which has got everything set up that you need to just start developing on it. So if you want that, the first link in the description, the blank template, is the one you want. And if you want to follow this thing along, that's the one that we're going to be working from. Let's jump in and just have a look at the setup before we actually start coding anything. If you download the repo and open it all up in Visual Studio, you'll end up with something that looks like this. And this is the setup of files that we've got along the left-hand side. There are a few dependencies that you will require in your Visual Studio code in order to make this work. So if we just go into extensions, you can find the ones that you'll need. We'll need Arduino support, obviously. So get the Arduino code, C++, again, because this is all written in C++, and you'll get the correct formatting and, error highlighting and everything. The LVGL project creator, that's the Light Versatile Graphics Library, and is the heart and soul of what we use to create this interface. If you've ever had any experience of using something like Material UI or a component-based user interface library, it's very similar to that, as you'll see when we start building things with it. And PlatformIO or PlatformIO, depending how people say it. I don't know which is the right one. Let's go for PlatformIO. And PlatformIO is the thing that will actually allow us to compile everything properly, get it ready to live on this display, which is now white, and actually allow us to interact between the computer and the display. And on that note, you're going to need a display. And this one in particular, you can get from Amazon for like 28 quid, or you can get the exact same one from AliExpress for 12. how much of a rush are you in? I think that's what it really comes down to. But it's the 1.28 inch ESP32C3 with this 2424 SO12 capacitive touchscreen. This is the one that this setup works for. There are other ones that are very similar, that are like an ESP32S3. The setup that I have in this thing won't work for that, but you can get it working with minimal adjustments. But this setup that I have in this code is specifically for this screen. So when you've got all of your extensions installed, if you're looking like this, you'll know you've got PlatformIO installed correctly if you end up with these extra things at the bottom of your IDE. And what these allow us to do is basically just test and upload our code. The big one that's going to be important is this one on the right-hand side here, where if we click on that, it will show us our different ports. Now I have this connected by a USB into my computer. So it is this COM8 USB, but sometimes it fails to connect, but I find that if I just leave it on auto, it doesn't do that. So for now, I'm leaving it on auto, but you could just choose this specific port. Then if we go to the top to Explorer, these are the files. And like I said, this is set up for this file in a couple of different locations. And the first one we're going to be using is the PlatformIO ini file here. You don't need to know all the ins and outs of this, but really it's just a configuration file that tells Visual Studio Code what kind of language to build for and what things to use. So it has a bunch of dependencies. For example, Lovyan here is a GFX library. LVGL, so he created some like log tracking and Chronos stuff for watches. For what we're going to do here, it's not 100% necessary, but they are all in this build package. And it's important to know that actually I got really stuck putting this together. And LVGL, he has a lot of very, very complex, like full watch user interface designs. And he provides the code for that. And a lot of this setup code is taken from that. And that really helped when I got stuck. So big shout out to him for all the work he's put into it behind the scenes. But then we have the setup for the Lolian C3 Mini, which is the setup for this particular board. It's just setting frameworks and partitions, basically how the board is set up. You don't need to know about it too much. One you do need to be able to recognize is this main H file. What we have in here is the setup for the board in the fact that how big it is, what the offset of the XY axis is, and this is really important. These are the various pins that connect the ESP32C3 to the screen. So it's the visual output and input pins that connect the way that it sends the visual to the screen, but also how it senses the feedback and the capacitive touch. All of these have to be exactly right. Now, if you're working on one of these things and you're using Arduino IDE, these are the settings that you will need. So I'll just give it a second for you to screenshot that bit. If you're trying to use this in another IDE, that will be really useful because these are the correct ones, I can assure you. Got that? Okay, moving on. LVConf is the setup for the Light Versatile, so it's the graphics library. Most of this you're probably not going to need to touch, but if you did want to use some of the examples that come with LV, you can set them up and utilize them in here, but I'm not going to go into that because we don't need to. We're going to be doing everything really in this main CPP file. So CPP is a C++ file. And in this, we're going to set up the entire application. At the moment, it's pretty bare bones, which is why now, as I've just uploaded it, it shows a plain white screen, which is basically nothing. So let me talk you through what the bare bones does for now, and then we'll start building our application. As usual with like if you've done any Arduino programming, the layout will be very, very familiar. It's exactly the same as an INO file. It's just all in native C++. So we have our includes at the top, which is specifying a version of the graphics library that we're going to be using. We include Arduino. This Lavian GFX is the equivalent of TFT ESPI, if you've ever used that. It's just a way of drawing things onto the screen. It's the base thing that actually draws the sprites onto the screen. So the graphics library that we're using piggybacks off that to actually draw things on the screen. Then we've got the graphics library itself, string, which is just, it allows us to work with strings. We don't really use it that much. Preferences, which is a thing to control memory in ESP32, so allow us to save things. So this is why when the program is done, I can set it to green, disconnect it, and connect it back up, and it's still green because it uses internal memory. And the main H, which is those setups that we've got here, the height and the width and everything, in case we need to use those at all. Then I've left a few things in here that I think, no matter what kind of application you're building, could be useful. So we've got the class setup at the top. Really, these things, you don't need to worry about this. This is pulling in all of those settings that from the main, the height, the width, all of the ports, everything like this, and it's setting up your board. If it's going wrong, you might need to change something in there. But if it's not, ignore all of those. You don't need to use them. Just we'll do the rest. LGFX TFT is just creating an instance of the graphics library, and it's naming it TFT. So if we want to utilize it later, we use TFT dot and then the public functions that come from it. Similarly, preferences, our memory stuff, is a shorthand prefs. So if we want to get things from it, we use prefs.get, whatever. Then we set a couple of constants at the top, screen width, screen height. They're never going to be duplicated, but it means we've got them there if we want them. And for some strange reason, LV doesn't come with the color black in it, and I like to use it a lot. So I've just created the color black, so I can just refer to that throughout. And this LV instance, so this is the light versatile. So all the functions that come from the graphics library are going to be in this format, LV something. You're going to see a lot of those over the course of this video. Buffer sizing, not too important. It's just what we have set up in there so that things are held in memory for a certain amount of time and blah, blah, blah. Again, don't worry about it. A few little things I thought were cool. So one of the first things I did was this screen dimming. So if I haven't touched the screen for this amount of time, 10 seconds, then it dims and it goes from 100% brightness, which is the default, down to the dim brightness, which is 10% brightness. I think it's really neat, and it feels a bit more finished, like you would do the same on a watch. If you were interacting with it and you stopped interacting with it, it would go darker after a while. So I think that's quite a neat thing to do, and it means for this instance, making something for a car, it's less bright and like glary in the car. And then there's the functions that support that. So screen brightness is literally just using that TFT that we pulled in here and setting the brightness to a value. So we can just use screen brightness and then a number between 0 and 100. Then we've got the check screen dimming. So this is just checking when was the last time that an interaction happened. Just trying to just continually check if anything has been touched. And if the screen is already dimmed, then it brings the brightness back up when you do the retouch. So they work in conjunction with these two functions. Again, these are not things you're probably going to really need to touch, but the display flush, you can use it to quickly flush out everything that's in memory if things are getting too slowed down. I haven't really used it for my application. Unless you're going really big, you probably don't need to, but it's good to have there. And same with the touchpad. This just is the code that is out of the box. It's what you need to put in there in order to sense where you're clicking on the screen and have that feedback into the right spot. So, the screen knows where you've touched it on the screen. And just the addition that we've got in here is the reset screen brightness. So whenever a touch is sensed, the brightness resets and sets itself to 100. And then we've got the setup and the loop, which you would get normally in any Arduino file. Bunch of stuff that you might recognize. So the serial begin for when we want to do logs. Setting up the preferences, so setting up the memory for my app. It's just called my app for now. We can change that at some point. And then a couple of default things that we will store in the memory and get out of memory when we want to. So we've got the rotation and the brightness. This is currently rotation 0, which means the bit there, that's down. And then these go rotation 0, 1, 2, and 3, I think. We're just going to stick with rotation 0. And the brightness is stored at 100. So when it starts at brightness 100 every time. We've got a few basic initializations that you would expect. There's the setup of the graphics library. DMA is direct memory access, which basically allows the memory to talk directly to the peripheral, to the screen in this case. So it doesn't have, nothing has to get processed all the time. So it's just a lot faster, basically. It's better memory management. Start write, which allows us to write to the screen. Then we fill the screen with black. For some reason, the screen isn't showing black, it's showing white. So might be an issue with that one, but I don't care, it's fine. And then set the rotation to the bin that was stored in memory. So our rotation is 0. So just so we know which way is up, down, left, right. And then we have the LV init. So that again initializes the light versatile graphics. And at that point, we've got access to the entire suite of components, which is the exciting bit and the bit that we're going to be using. Couple of little setups here that you're probably never going to need to touch. So it's the setup of the display and the setup of the touch. So it's making sure we can draw to the screen properly and we can read back the input from the screen properly. You're not going to need to touch those most likely. And then I just set up the default screen brightness at the bottom. So that's brightness of 100. So that's then, set in memory that that's all being worked on. And finally, we just serial print, finish setup. So I know that it's finished. A tool that you're going to want to use consistently throughout doing this is the library for LVGL. If at any point you go, how does he know how to write that? It's because the answer's in here. I've literally just spent a day and a half building this thing by going back and forth to this library, figuring out what events each different kind of component had, how I could hook into the different visual elements of them, and just figuring out at a bit of time. So for example, an arc, which we're going to use momentarily, it'll show you how to set up the values and the range and the rotations and all the visual things to do with it. So I've just spent a lot of time looking through this library. Also, if you need to use it, ChatGPT is quite good. It does know a lot. Make sure you tell it, when you first tell it, I'm using LVGL version 9.2, because in version 8, there are quite a lot of differences. And if you don't specify the difference, it sometimes pulls old code. But it was really handy for helping me just debug a few things here and there. So let's start by setting ourselves a couple of simple things that we want to do on this. So we'll start, if we just write it above setup here, we want to add a black screen, so home screen, which is going to be the background of the screen that we start up on. And on that screen, we want to add an arc, so the band around the top. So add an arc, and then add a power button in the middle button. And then we want to make power button turn arc and button on or off. So we'll start with that. That's like our base level without the color picker or anything like that. When you're thinking about building an application like this, you want to think what components and what things are going to be local and what things need to be global. And the way to think about that is if you've got for example, a button with a label on it. If the label is never going to change and the text is never going to change, the label can be local to the button. So it's part of the button, but it doesn't need to be part of the entire application. Whereas the button might need to control itself, but it might need to control something else, which is like in this instance, we want to switch a power button and it changed the arc. So we probably want to make the definition for that thing global, which means anything else can access it. So what we'll do to begin is by defining the home screen, because that's what a lot of our things are going to appear on. And even though it's a screen, really it's an object. It's a thing that a bunch of stuff appears on. And when we're creating things with LVGL, we need to use LV object T. And this is basically the type for a LVGL object. So it's the LV object type. And everything, whether it's an arc or a button or whatever, has this. It inherits this. So the stuff that's available in this is available in every component. But you're making a base line, like a div, if you are doing HTML, that's its type. And we're going to start with home screen, and that's it. Nice start. But because it's an instance of an object, we don't actually create it directly. We create it as a pointer. So we're going to create a pointer to an object. If you want to get into pointers versus non-pointers in C++, go and spend some time just researching it and figuring out what it is. Basically, it's just a way of saving memory. You're not reproducing things. You're creating a pointer to where that thing is stored in memory. But they're used a lot, and it's probably a key thing to know. So yeah, go spend some time doing that. And then on that screen, we're going to have another object, which is going to be our arc. So let's call it a color arc. And then we're going to have one more, which is going to be power button. So we'll start with those three things. You could just come down into setup, come to just before, after screen brightness here, and just write all of your code down here. But it's not going to be very readable if we do that. So let's break it down into some small components. And we'll start with make home screen, which will immediately wiggle because we haven't made it. We need to create a void because it's not returning anything, it's just making something. Make home screen. And here we're going to just do the setup for our home screen. So even though we've created the pointer here to this being an object so that we can access it in all of the functions, we actually need to define what it is now. And this thing is an LV object that we need to create. And it's not got a type, it's just a blank object type. So it's a null. And like I said, LV objects all inherit the same stuff. They all have the same functions that you can access. And a common one we're going to be using is LV object set style. And then the various styles. And as you can see here, there's loads and loads of different kinds of styles that we can do. Anything from outlines, margins, all the kind of stuff you would consider in like a web development package. What we're going to do for this one is background color, so BG color. But what we need to do is we're saying what object are we applying that to first. So we're going to apply that to the home screen object that we've defined here. What color are we going to define it? And I've got that black that I decided to define at the top of the page here, this LV make color black. So I'm going to call it black. And then what part of the block are we applying it to? So in this case, it's LV part main. Now every single component has got a main, but some have got other ones as well, as you'll see as we get into it. Like an arc has got the main, and then it's got the indicator, which is how much around the arc it's got, and it's got the blob, which is the button thing that's on top of it. So if you need to know what parts these have, again, like I said, they're all in the component library here. So if we're in arc, for example, we've got the parts, so the main, the indicator, and the knob, as I said. So that will set our background color to black. And I just want to make sure it's got like a 100% opacity. And we do that in a similar way to this. So if we go to the set style here, and we didn't know that what the opacity was, we could probably figure it out by scrolling down, and it's actually background opa for opacity. Again, we're just going to apply that to home screen. And again, it's got specific shorthand terms. So there's opacity. So opacity here that goes from 0 all the way through to cover, which is basically completely cover it, 100. And then what we're applying that to. So the LV part main. So now that we've made this home screen, it exists. But if we were to upload it to here, in fact, we'll do that. We can just check the build at the bottom here with this PlatformIO build. And it'll just take a second to run through, scan all the dependencies, make sure that everything is in order. It does get faster each time you do it. This won't need to run every time if we don't make any changes to this PlatformIO ini file. It's just I've just made some alterations to it, so it's just running through this once. But full success. And then we can click upload next to it, which will basically just recompile it again, but then upload to here, and you'll see it tick through the percentage upload. And when it does, if it's going correct, your screen should go blank as well. There we go. You can see I don't need to press anything on this board. It just goes. Sometimes it does fail and you just need to unplug it and plug it in. But yeah, as you can see, the screen's still white, even though we've set this black home screen. And it's because we haven't actually told it to use home screen. We've just created this home screen object. So if we come down into our setup, after we've made the home screen here, we can then do LV screen load home screen. So this LV screen load is just a shorthand way of, well, it's not a shorthand way, it's just the code to tell this thing, this is the screen that you should be showing right now. So we'll use that a bit later on in order to move between different screens by altering which screen we're currently loaded. So if we just give it a second to upload, when it's done, we'll see that now our screen is black, because we've allocated that background color to now be live, and that thing is just taking up the entire screen. So that's sitting as, basically it'll be overlapping, it'll be sitting as a square kind of around the outside edge of that. So the next thing we want to do, we've got that add a black home screen done, we want to add an arc onto that screen. So when we're making the home screen, once we've set it up here, we can then add the color arc. The general rule of thumb is if you're going to do it this way, you'll then need to put the function above the function that you called it in. So we'd have to put this one up here. Otherwise, this won't know that this exists, which you can see if you put it after. It's like, I don't know that this exists properly. I mean, it's recognizing it now, but sometimes you'll get forward referencing errors. It can be a bit of a pain. So we've decided already that we've created the color arc, you know, its instantiator at the top here. So then we can just create color arc. And whereas the last one we did LV object create, this one has got a special type because it's a known component, so, or widget. So it's arc create. And then we've got to tell it where we're going to create it. So we're going to create it on home screen, which is why it's important to do this up here, because otherwise this wouldn't now know that home screen existed, and we'd have to pass home screen into here and then define it in here. You start getting all this thing of having to pass components around into all their subcomponents. It just becomes a real pain to manage. So it's a lot easier just to stick your widgets and your home and your screens at the top, and then they're just all ready to access all the way through. All you have to remember is that the first instance where you build it here is you don't add the typing and the pointer like this. Otherwise, this and this do what's called shadowing, and it gets confused about which one's which. It will break your code. So we're going to create an arc anyway. And like I said, there's a bunch of stuff bunch of code in here and a bunch of examples that will show you how to draw these arcs. I'm not going to go through it a line at a time and write it all out because it's going to take too long. Instead, I'm going to paste in the setup and then I'll talk you through what it means. And bam, right. So a lot of these are going to make sense just by reading what they are, but I went through quite a bit of trial and error of getting a design that I liked, and this is the output of that design. So the size, if you imagine it as a square, it's how big it is as a square, even though it's an arc, or it's a circle like this. So it's the square that encapsulates it. Our screen is 240 by 240, so by doing it by 200 by 200 it gives me a nice bit of padding around the outside edge. If you wanted to do it all the way up to the edge, you could just call that 240, 240, or you could just use this height and width values that are already predefined in our setup. Then I do some styling on the arc itself. So apply to the arc the width of 20. So I've given the thickness. So this bit here, I've given a thickness of 20, which is about what this one is, I think. They haven't set it, but usually it's thinner than that. I think it's 10 as default. And I've set that to both the indicator and the main. So in this part here, this blue bit is the indicator, this bit is the main, and it's possible to have them as different thicknesses. So like the indicator looks more grand as it comes round, but I've set them both the same. Then I've set the arc background angles from 120 to 60. Okay, so when you're looking at one of these screens, 3 o'clock on the dial, so here, is 0 degrees, and then it goes clockwise around the clock. So it's 0, 90, 180, 270. And if you saw it, my thing, mine was like a horseshoe around the top with a gap at the bottom. So I've set my angles here to go from 120 through to 60, which means it starts the arc at 120 degrees. So if that's 90, it's 90 plus 30, which gives me that bit of space. And then it continues going around until it hits 60 degrees, which again is 90 at this side minus 30. So I've gone 30 degrees either side of the bottom, which gives me that around the top. So that's what that background angles does. It's just setting how much of it around the arc you want. If you set this from 0 to 0, it'd be a complete circle. Then I remove the style of the knob because I've removed this knob because I'm not actually using this as a slidey thing. I'm just using this with a click event on it, but I don't care what value this is set to, even though it is actually recording that, but we'll get to that in a minute. Then we'll set the color. So this again is a special one for the arc. So set the style of the arc color, setting that arc, make a color 25500, which is red, green, blue. And then apply that to main. So apply that to this background bit and apply the same color to indicator. So as you can imagine, with this, without the knob and both these two bits being the same color, it just looks like an arc. It doesn't look like a slidey arc. Then we can set the range from 0 to 100. Actually, that's not really needed. Neither is this set value 100. So we can, get rid of them. And then we choose where we're going to draw, where we're going to align this arc. And we want it bang center in the middle of the screen. So we do align the arc to the center. And then 0, 0 is any offset. So top and then left and right. So if we give this 20 here, it would move down 20 pixels, but we'd want it bang center. So that's what we're going to do there. So this should draw us that red arc. And if we just upload it, we can check that everything is okay. And it's really important as we do this to check it as we go. So it's just booted up and sure enough, there we go. One red arc that goes, like I say, from 120 degrees all the way around. And even though, you see, it actually was dimmed, which is why it came brighter again. If I touch on this, when I move the finger here, I am actually moving that arc around. But because I've set it all to be the same color, you don't see that. it's just a way of allowing me to use a visual component that I want without having to take all the functionality with it. So now we've got our arc in place. We wanted to put a button in the middle on top of it. Let's do that. So let's say just keep our list update. So unarc, add a power button. So we've added the color arc. Let's add a power button. Similarly, we'll do the same here. Let's take that start, add a power button, and it's not going to be arc create. You've probably figured out what it's going to be. It's button create. And again, we're going to create it on the home screen, and we've defined what it's called already because we're clever and we've done it in advance. We called it power button. So power button is that. Right. Again, our power button has some design aesthetics that I've already done. We're going to align it in the center, bang center. Going to add a flag to say that it is checkable, which means it's not just a button. It's a button you can, like, imagine a click-in button, or it's clicking a checkbox. So it can have an on state and an off state, which is what we need for this application. So we need to be able to say turn off, and it just stays off, not like it's a persistive touch. So we set a flag for the power button to say that it is checkable. We set its size, so it's actually a lot bigger than that little UI element that I had, that little power button. But you don't see a lot of it. So we set its size to 120 by 120, then its radius to 60. So it's actually round in the middle, even though it is technically just all black, so we don't see it. But if you could see it, it's a big round button in the middle. Just because when I'm in the car and things are moving and I want a larger clickable area, I don't want to be trying to necessarily hit a really tiny touch point. Then buttons, especially buttons that have states that you can manage, like a checkable state. When you press it and it stays down, it has a shadow to show it. So, and it has a border. So we get rid of those by saying the power button has got no border and no shadow on the main part of it. So that's what these do. They just get rid of that default. Now that we've got a button, we want to put the logo on it. And there's actually a bunch of symbols and things built in. If we go into the font page here in the documentation, it'll show you how to change the size of the font and to make bigger fonts. So all this stuff here, this is what we're about to do. So we're going to pick a bigger font size. We're actually using font size 40. And then there's a bunch of symbols that are built in again that we can use. And there's the power symbol, which here, no, you can't see that. Power symbol there with the on-off, that's what we're going to use for our on-off button. Again, I've written all this code, so it would be superfluous to go and write it all again. But what we're going to just do is, I'll talk you through it, is we're going to create a new style that we're calling style large text. Basically, there's just defining something that we can then just use. So we initialize that style and we set what that style is. So this style is Montserrat, which is the default font, and it's size 40. So if you wanted this to be bigger, you could use 50 or whatever styles there are. Goes up to 48. We're using 40. I felt it was the right size. And we create a label, but rather than up here, like we had to instantiate it here with the pointer, now we can just create the pointer when we actually just create the label, because it doesn't need to be global. This can just be local, because this label is just going to apply to the button that it's alongside or it's the parent of. So it doesn't need lots and lots of extra information. And then we're going to set the text of that label. So we're setting the text of the label to that power symbol. And like I said, these are just some shorthands for a bunch of icons that are available. And then we center the label, and then we add the style that we just defined above it to the label, and 0 is, I'm not sure what the third selector. Oh, so it's not to any specific part of it. It's just to the label. So that's just a 0. So this will give us the power button in a bigger font on the button in the middle of the screen. So let's just take a look at that and see what that looks like without all of like the button styles applied. Because you'll see it'll apply a load of default styles that we then need to go in and overwrite. So we've got this now. So here's our arc with a button in the middle, and the button, as you can see, has blue and red as its default styles. There would, when this red one came up, be a shadow underneath the bottom and a little bit of a border, but we've already defined that this thing has no border and no shadow no matter what its state is. So those things don't apply. But what we want to do now is make the outside black no matter what, so we don't actually see the button, but then the text, the icon on the inside is either dim or bright. So just like we had here, we're going to need to define a couple of more styles. So we'll start with a style which is the style when it is unchecked. And then we just need to get this initializer again and put this style unchecked into here. So we've initialized that style, it exists. And what do we want that style to include? So that LV style will set a background color. And that's applied to that style. And then what is the color? So we've already defined, like I said, black, and then that's that. So the background color is going to be black. And while we're here, we can just do style checked, because the style checked color also wants to be black, because the background's not going to change either way. It's going to be black in both instances. So checked background black. Actually, that one's unchecked. This one's checked. Background black. So what we then want to do is have the style when it's unchecked. So when it's off, it's like a dark gray. And when it's on, it's bright white. So we can start with the white. It's easy. We can do LV style set text color, funnily enough, and apply that to the style. And we can use, there are some like palettes and some default colors available, and white is one of them. So that will be checked icon is white. Now we want to have a not white color here. This one needs to be unchecked. So there is a checked color make, which we've used a couple of times. If we wanted it to be like 40, 40, 40, which is a nice like dark gray, but we're probably going to want to reuse that for a couple of other things later. So what we'll do is at the top where I've defined black, we'll do LV color T dark gray, and we'll call that. Then we can just refer to it as dark gray. Groovy. So we've defined what these two styles are, but we need to now tell it, use this style when it's checked and use this style when it's unchecked. It's fortunately pretty simple to do. And you can use it with every single object because it's a general object function, and it's add style. We're going to add the style, say what we're adding the style to. Adding the style to the parent, it's a power button, because it's got the background and the label is a child of the back of the button, so we can just add it to the button. We can, when it's style unchecked, so style unchecked is when it's off, so when it's in its 0 state or its normal state. This can be used as 0 or LV state normal. No, default. And then we use the checked style when it's in its checked state. So now when it's unchecked, it should inherit all of these style unchecked styles. And when it's checked, it should inherit all the checked styles. Let's upload and test. So sure enough, it boots up as we expect. It's currently off by the looks of things. So it starts off and then we switch it on. And it's off and on. So there's going to have to be, down the line, a case where we ping memory and say, is this thing starting on or off? Because that's going to be something that we store and retrieve. But for now, we probably just want it to start on. So we can do LV object add state and then set it to whatever state we want. So we're going to set the power button to be this checked state. So now when it starts up for the first time, it starts as on, starts as checked, which means it's in line with the arc, which is currently on. So that's, from a visual perspective, that bit working. But what we now need to do is when we press the button is the arc needs to disable as well as the button. So how do we do that? We do it by adding obviously some code to the click event of the button. So we need to add a click event into this button. And that's done with LV object add an event callback. So there, add event callback. So what to do when something has run. So on the power button, we're going to do whatever we call the function. So let's do power button click event. And then what action are we applying that to? And each type has different events, but all of them have the common ones, and event clicked is a common one, basically means you've touched that object. And then do we need to add any extra stuff? Do we need to pass anything into that variable? And in this instance, no, we don't. If we hadn't sorted out these instantiators at the top, we might need to like pass the arc in so that we can affect the arc, even though it's not actually the thing that we're clicking on. But because we made them global, we're not going to need to do that. So we can just create a new function, which is the click event. And then we can get the event with LV event t as its type. And just, it's a pointer that would a pointer to E. So E will just be our shorthand for event. These click events expect one parameter here, and that's the one you have to do. If you were passing also in extra things, so user data or whatever that might be, you would define it afterwards here, but we're not in this case. We will later though. This little bit of code that I'm about to write was a quirk that I didn't expect when I first wrote it. It didn't quite work how I expected, but this is why you learn off a YouTube video rather than spending literally 2 days trying to figure all this out for yourself. The way to differentiate with a button whether or not it is checked, so if it's got a persistent state where you can click it on and click it off, is with this code here. So let me just do the else and then I'll explain it. So we get the state of the power button if that state is true and it is checked. So you have to actually do both of those in order to correctly say, is it checked or not? I thought you would just be able to do the state checked. You can't, you need to do them both. Once we've got that in, we can do code when on, otherwise code when off. So roughly speaking, what we need to do here is set the arc to the default color. So arc on and arc off. Right now, our arc is red, RGB down here, make color RGB. Again, that arc is going to need to be dynamically colored, but not right now. Let's get things working one little bit. Let's do one little bit, get it working, and then build on the next piece. Because arc is defined as a global thing here, we don't need to then worry about importing it or anything. We can just apply styles to it. So we've got this set arc color. We used it down here below, so set arc color. And we're going to basically just reproduce this little bit of color up here to set it when the power button is on, the arc is on. In this case, it's red. And we have to apply that both to the main and the indicator, because you remember there's two parts and that thing is sliding. So the back bit could be revealed. And then when it's off, we're going to make it both to have that dark gray. So dark gray. Let's just test that bad boy. Hopefully you can start to see how you use these inbuilt functions that come with LVGL in order to quite easily create these things. Once you know the layout, so knowing that it's like create an object, then what to apply to, what you're applying, and then to a subpart if necessary, it starts to become quite easy, and it's pretty simple to put together bits of code. What have we got? So it started on. If you remember last time, it was started off. So that's a good start. If we click it, there we go. It all goes off and then on, off, on. Now, if you were never to change the color of your underglow, you could stop there, because that would be a perfectly good underglow controller that you can just stick in your car and you can turn it on and off. Or if you wanted to use this in your house and have it stuck on the wall, it's just like a cool little display, and you can just press it and your lights in your house come on and off. That'd be pretty neat. Or you could use the actual arc and have the slider to do dimming in your house with the touch. I think that's a really just a clean solution for a single light thing. And that's pretty good so far. But we're not the kind of people that just want to have red on the underglow. Not only because it's illegal, we would never do that, but also we want to have the choice of changing a few different colors. So we're going to get on to part 2, where we build a second screen with a bunch of color pickers around it. Now you've seen how a lot of this goes together. I'm not going to go through the whole rest of it a line at a time and write it with you, because this video will be 3 hours long. Instead, I'm going to dump a bunch of the code onto the screen in double fast time, and then I'll talk you through it. So just bear with me while I paste over some code that I've already written. Right, okay, so there is actually quite a bit of extra code here. 2 or 3 major things have happened. Firstly, there is a new screen that has been created, and you don't have to think of where the screens are located, because all you do is add an animation type. So if I'm saying when I click an event, the next screen comes from the top, all it does is animate it as if it has scrolled up and down. You could do an over or an under, it doesn't matter. So we've got 2 ways of, one way of moving up and down. When I click on the arc, so this is the event now for the arc, I'm going to animate, so screen load animation to the picker screen. So my color picker screen is called picker screen. And it's going to use this animation type. So load animation move bottom. So it means it's going to move the screen I'm currently on to the bottom. So it moves it down. So as if the new screen is coming from the top. It's going to take 400 milliseconds. I'm not sure what the other two parts of that do. 0 and false. I think this is a callback at the end. I'm not 100% sure what those 2 parts of that function do, but it doesn't really matter. regardless, what you need to know is this, the animation type. So when we click on the arc, that new screen is going to load. On that new screen, if you remember right at the start, there's a button at the bottom that if you press, it brings us back down. So it's the back button. So there's a back button click event, which goes to the home screen. And that's got the move top. So that's making it animate in the other direction. So that's the thing that handles the movement between those two screens. So we've got the arc that takes us up and the back button that takes us back down. So we've got a new couple of global things. We've got the picker screen because we want to be able to access it anywhere. And we've got the back button because we want to be able to access it anywhere, because this is a nice little marker that shows me when I've successfully pressed a button. It's just a feedback thing. Also, one thing that is needed to do is we need to store and have the colors change properly. So when I click on blue, when I go down, the arc needs to be blue. In order to do this, we use the internal memory and we store the colors to the internal memory when we change a color. So when we click on a new option, we store those values in memory, then we reset the color on that arc. So we, much like how we set it to red or gray, we set it to that color. And then we also set it to the pref's internal memory. And then when the whole application loads, so when you unplug it and plug it back in and the whole application loads, it's remembered that color and sets that as the default instead. Also, one thing we hadn't started to talk about, but was obviously going to be a thing that needed to happen, was it needed to remember if it was on or off. So when it boots up, does it automatically switch the lights on? Probably not. Only if it was on in its previous state. So it needed to remember if it was on or off. So I've created power state as well. So these all now are global at the top. They're just defined so that I can reuse them everywhere. So they are the red, the green, the blue values, and the state of the power. These are separated into red, green, and blue because of what we're going to do in the next video when we start passing these details from this ESP32, which is on the back of this little screen, to another one, which is actually attached to the lights, but they're in different parts of the car, so they need to be able to talk wirelessly. So that's going to be pretty cool. So that's what these three things do. What I should actually probably do is just upload this code to here, because then I can talk through it with you a little bit more easily, because it's easy to see what's actually happening when you can see the output. So as we were back when I first showed you this, it is on, and it has blue currently, so it's just dimmed, so you can see it's gone dimmer. If I touch it, if you touch anywhere on the arc, it goes up, like I said, and then the back button there goes down. So this is the back button at the bottom, and that needs to be global, because if you can see right now it's blue, which is the same color that we're currently set to. If I change it to red, it goes red. So it's just a feedback loop that allows me to see whilst I'm on this screen what color it's actually already set to. And then if I have gone onto this page whilst it's off and turn it to green and go down, this is still off, but then I turn it on, it's green. So at the moment it's on and green. If I unplug it and plug it back in, it'll remember and it comes on green. But then if I make it red and off, and I unplug it, turn it back on, it's off, and now it's on again with the red. So that should mentally catch you up with what we're doing, make it a little bit easier to visualize. So we set a gray. Those little picker buttons, I had to do some playing to get the sizes and the positions of them right to feel good. And obviously you could have set more colors and had them smaller, or you could have put a picker wheel in there. I didn't want to faff about. I wanted to know that I generally use, I'll be honest, I generally use two colors, maybe sometimes three. I use like a orange or a purple. They're really the only two underglow colors I ever run. But, you know, there's instances when I'm at shows and things where I might want other colors, and they're probably going to be the main primary colors you see there, plus white. So it made sense that 7 colors was sufficient. And in order to do that, I tried a few different sizes of them, and 50 pixels as the size, the as a touch point seemed about right for that screen. So we've got our events. We've got the power button click event. The one thing that's changed with the power button click event is we've got prefs, put power state 1 and 0. So when we're using prefs, which is our internal memory in the ESP32, we can get or put values. So we can ask memory, what have you got stored? Or we can say, store this new value. Power state is the name that I've called the memory power, whether or not it's switched on. So when you turn this system on, when you click the power button to turn everything on, we set the memory to 1. When we turn everything off, we set the memory to 0. That's how it knows when you unplug it and plug it, you need to put it back in. When I said earlier that we would use, at the end of the callback event, that we would use that to pass some data through, this is where we use it. So we've got to create a structure. And in this structure, we're just basically defining 3 things, red, green, and blue. So we can pass them through as one object. So we can just pass color data and then extract the information out of it. So pass it as one thing. So color data is the structure. So those buttons around the top with all the different colors on them have got this click event on them. When we click on, say, a red one, we pass red 00, so 24500 is red, green, blue, and it extracts that information out of this structure that we've passed into it. We'll show you how you do that in a moment. Sets the global values, so global value red, green, and blue, which are these ones we set at the top, red, green, and blue. We set them to the new values that have been passed by clicking on the button, and then we save those values into memory. That's it, really. Then we update the arc color, but only if the power is on. If the power is off, down below, when we've clicked red, down below the arc is gray. It needs to stay gray. We only do that in the instance that the power is on. We set the arc to the new color. Otherwise, we just leave it gray for now. And then on the back button, the button at the bottom with a little down arrow on it, we set the color of the arrow to that red, green, blue value that we passed through. So that's our little feedback loop. So that's all that button does really, is it sets the arc color and it sets the drop down arrow color. Our make arc function has changed a slight bit. Now, when it's created, it'll make the color based off global red, green, and blue, which are defined at the top of the page. But if I just jump ahead to the setup function, that global red, green, and blue are now defined from memory. So we say, get the integer value stored with the name glow red and set that to glow red. Same with glow green, glow blue. And if they're not stored, if they go, okay, give me the value for glow red, and it goes, I don't have glow red, I don't know what that is. It goes, all right, okay, I'll use 140 instead. So my fallback is 140.0255. So if you're going to use this app for the first time, you'll get purple because you don't have the memory values stored. So you get 140 red 0255, which is a purple. Also, you notice I've changed my name to Glow App because that's, for me, what it is. It's an underglow app. The only other thing I've changed in the initialization, in the setup, is to make the picker screen as well. So it makes the home screen, puts all the stuff on it, and then it makes the picker screen. So they all initialize like one after the other because this is a single threaded thing. So it'll do one and then the other. It doesn't try and do everything all at once. So if we just check that out, our picker screen is very, very similar to the home screen. It just creates a new object with a black background that fills the whole screen. That's the entire thing. But then instead of making the arc and the power button, we make the back button and then we make the color buttons. The back button is super simple. It's just, again, like what we did before, we created a button, we aligned it. So if we put it in the center, but then we moved it to the right 0, but down 80. And that moved it to a point where the outside, the bottom edge of it was the same distance as the arc edge. So it's in the same amount. So that's why it feels consistent, because whatever page you're on, there's that same 20 pixel gap all the way around the outside edge. The size is based on that button size that we initialized up at the top. Right up here somewhere. I don't need to go back to it. You know what it was. We set the size, we set the radius, which is just, I did this as size divided by 2. So if it's a 60 by 60, it's got a radius of 30, which will make it a circle. Set the background color to red, green, and blue, which is passed into this color button. That'll make sense in a minute. I'll show you this instantiator. And then, much like we did before, we get rid of the border and we get rid of the shadow because sometimes they show up for buttons. So then we used that structure before. So we made a structure called color data and we gave it the format red, green, blue. So we create a new variable or a new holder for that, a new array called data. And we set the values red, green, and blue into color data, but with the name data, but with the style color data. This just sets all the sizing of it, everything correctly. But then when we do the callback event, so when we're clicking on one of those buttons, we do the color click event, which we just looked at, but then we pass it in data, which means it's got data red, data green, data blue. So when we do that click event here, color click event, color data is there. So this data red, data green, data blue is as extracting them. So we compile it down and then extract it out. It's just a nice, neat way of passing multiple values into one variable. But I didn't want to have to manually create all of these individual buttons and do all of this every time. So instead, this is make color button. So all the time it's going to be on the screen, which is the picker screen. And the arc, actually, these two bits don't need to exist in here anymore. I updated how this function worked. So that make color button there, all of this can just go. So I can get rid of this in all of these. This is what I'm saying about if you're clever with your global declarations, you can avoid having to pass a load of stuff about unnecessarily. So make a color button does this. So all this is left, top, and then color in RGB. So the first button goes 57 to the left, 57 down, and is a red, so RGB. So that's that one. It's 57 left, 57 down. And because I've done this as 8, so the top and the bottom are like up 80 and down 80. The side ones are left 80 and left minus 80. And then in order to get like it even, I just have to do a little bit of maths. And it turns out that these 4 corner ones are 57 from the center. So 57 left, 57 up, or 57 right, 57 down, in order to get them into a point where they're all equidistant from the edge in a perfect circle. So that's what all these are. So there's 4, well, there's 1, 2, 3, 4, which are the 4 diagonal ones in the various left, rights with their various colors associated to them. And then there's the top and then the 2 sides. And the bottom is obviously taken up by the back button. So that's just a really simple way of doing that. So when we've started the picker screen, we've made the back button, then we made the color buttons function, which then does the individual color button function. There was probably a way of doing this with maths, but I wanted to be able to just define the colors. So if you wanted to have your own selection of colors, all you would do is come into here and go, actually, I want my first button here to be white. And I want, you could just go to a color wheel or a color picker, pick whatever colors you wanted and replace them just with these values, and it will just set up. And because it then just passes these values inside and out of the various functions, you don't need to update them anywhere else. It'll all just get done in here. Generally, that's it. That's the entire app. Now, this took me like a day to basically build because I've not used LVGL before. So this may not be the most efficient way of doing this, but I think it's pretty close. But I think it's pretty self-explanatory. And the good thing about this LVGL library is you can't just use it on these little round screens. You can use it on all kinds of different screens. I've got some bigger touch screens, so I'm going to have some interesting things to build on that as well. Now this isn't finished. It's finished as far as the user interface goes, but it's not finished in the terms of this entire application and the point of me doing this. There are 2 further videos coming. First one is going to be something I'm going to be working on in the next couple of days, which is going to be integrating ESP Now, which is, if you don't know, it's a very, very good Wi-Fi stateless communication standard that allows me to broadcast any changes from this, and other devices which use ESP Now knows to listen for them. So the work that we did a few days ago, getting an ESP32 to talk to a strip of Chinese underglow lights, will then be used on that as well. We'll put ESP Now, and then we'll get the 2 things talking to each other. And once they're talking to each other, when I do the change of color here, it'll broadcast, hey, I'm now this color, and send this color into the ether. And this other device will go, oh, I'm interested in that. And it'll get that, and it'll set the underglow based on the color that we use here. So this is going to be a wireless, stateless, persistentless, just a cool like communication thing. And the reason I have to do that is because this is going to live in my dashboard, integrated into the dash, whereas the controller for the underglow sits underneath my boot, and I don't particularly want to have to wire them. I think this way allows me to like create different ones of these, and then I can just chop and change them, or I could integrate this into a watch or something as an app, and then it would still work using, as long as the communication standards are correct. So we're going to have another video in the next few days where we get all of that communication working, because I think it defines as well a standard for doing like neat communication stuff. And as well as part of the next video, we'll be designing and creating the PCB and the enclosures and everything for this in order to actually install it in a car and run it off a 12-volt system, even though they're all 3.5 volt, or in the screen's 5 volt. We need to obviously do all that, you know, volt handling and all that kind of stuff, and power management and blah, 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 blah. So that's all going to come in the next video on this channel. And then actually taking it, building it into my custom center console in my 350Z, which I've just spent, you know, a week and a half building this full custom 3D printed fiberglass center console with a new space for this underglow controller. I need to do a new 3D printed panel and stuff for this, and then integrate it into the car. That'll come on my other channel, Valentine Autos. Link to the other channel is down below, I guess. But more than anything, I hope that this has made you realize that actually creating these neat little displays to do cool stuff isn't that hard. And doing this with LVGL on this little screen for the first time, actually me using, like I say, this package, has got me going, actually there's a bunch of stuff we can do with this. Like I say, I am working with AliExpress and PCBWay, who will be providing a lot of the component stuff for this. So big thanks to them for reaching out, and I'll be included a lot in, especially in the next video. But like I said earlier, if you want this component, it's available both on Amazon and AliExpress. If you can wait for AliExpress, it's half the price, so it's worth it. I'll link it below where you can get it, and all of this code is available on a repo. So like I said, the blank version is available, and this full finished bit of code is available, finished. Anyway, that's it for this one. It's like 11 o'clock on a Saturday night. How fun am I? I'm sitting here with my dog who's fast asleep. And so I'm going to go have a hot chocolate and wash the day away. Whatever you do with the rest of your day, if you've got much left of it, have a wicked one. And I'll see you in the next video. Take it easy, peeps. Bye-bye.